We often hear that only 15% of the oceans has been mapped. Well, exactly what does mapped mean? And sort of we're trying to say that sort of we've got the regional global scale of maps, but the 15% means we've got the slightly higher resolution, the 100-metre resolution of the deep ocean. So we can actually see that. So when Captain Cook was discovering his lands of Australia and places like that, he was looking at the land, and he would take profiles from what he could see from a ship, and he would occasionally take a lead line, which he would lower over the side of the ship to see how deep the water was for safety of his navigation. Now, what we're starting to do is, instead of using a lead line and going down thousands of meters into the deep ocean, we're using sonar as a sort of a sounding to understand how deep the ocean is. We send down a sonar signal, we measure the time that it takes to go down to the bottom and back up again, and therefore we can actually see the time it takes, and we know how fast that sonar signal travels, and therefore we can work out the depth. So that's a single ping of sonar sound that we use. But now what we start to use is multiple pings, where multiple pings go down at all different angles all the way from the ship, and each of those individual pings come back, and we receive all those pings, at which we can make a swath of depth soundings, because we know the angle and we know the time that they took to come back up. And so therefore we can build up a set of pings, and we move the ship forward, at which point we can then take more soundings and slowly build up an idea of the depth of the ocean and the shape and the morphology of the sea floor. And from that morphology we can start to understand some of the processes that are going on the sea floor. Now, that's done from a ship. Now, the ship is possibly 3,000–4,000 meters above the sea floor, and so therefore our angled beams can only get a certain resolution. Now, what we really want to do is to get down to really fine resolution and actually sort of survey the sea floor at a much higher resolution. And that higher resolution can be achieved if we then send some of our remotely operated vehicles, or maybe even an autonomous vehicle that flies really quite close to the sea floor. And because it's close to the sea floor, it can then send out again the same kind of sonar pings, but because it's much closer, we can actually do things in much higher resolution, and therefore pick up the morphology of the sea floor in much more detail. And this is when we start to detect some of the biological communities of the sea floor, and sort of try and work out what's going on there. So life on the sea floor can be maybe determined better, rather than the big regional scale or even the global scale that we have got. So we've moved from the Captain Cook, where he just did the coastline. We've now gone deeper, and sort of with single beam echo sounders and multi-beam echo sounders, going right down to remotely operated vehicles very close to the seafloor. We've surveyed quite a lot of the seafloor with our multi-beam systems, which covers about 15% of our oceans. And if we want to think about that, that's probably about the size of Africa in terms of coverage of the sea floor. But then when we get into the really high detail, the ROV, the remotely operated vehicle type areas, it is an absolutely tiny amount. A, because it's very, very high resolution, but also it is a very, very new technology, and is only really coming into its own in the last couple of years. And the area we've covered now is probably only about, if on a global scale, comparatively, about the size of Tasmania or something even smaller than that. It is really quite a small area. So there's loads more to do, and it's really quite exciting to think about what we've got still to discover down on the seafloor. We've probably been to most places on our planet, but the deep sea has got all kinds of different life. It's got interesting minerals that could be used for industry, and also sort of there are other things down there that I'm afraid we don't even know about yet. It is a world of discovery. I make maps so that we can then go and find maybe places that have interesting changes in depths and different morphology, so to see the processes that are going on.